Hey guys, Mr. Martin back again, talking to you tonight about algebraic and geometric properties. You guys have been using a lot of these properties since your Algebra 1 days, so I know some of them will be review, and there are some new ones I'm going to show you today as well. So here we go. Alright, the first one that we are talking about is obviously the distributive property, which you've seen for a long time. That just simply says if you have a number like 3 outside a set of parentheses, and you have something like x plus 2 inside the parentheses, you guys know that that's the same as 3 times x plus 3 times 2. That's nothing new for you guys. Just wanted to make sure everyone knew that one. Okay. The next set of properties is something that you also have been using since Algebra 1 days. They're the properties of equality. And these are the ones, if you remember, that says whatever you do to one side, you have to do to the other. We have one where if you add something to one side, as long as you add it to the other, you can keep the equality. Same thing with subtraction and multiplication. These all seem really redundant, but it does cover all 4 operations: addition, subtraction, multiplication, division. You guys remember, whatever you do to one side, you have to do to the other. Again, that's a quick review for you on those ones. Also a review is the substitution property, which says if A equals B, then A can be substituted for B, or vice versa in any equation or expression. You guys have been doing that for years, taking out an x, for example, and putting in a 2 in an expression like 3x minus 6. If x is 2, you take out the x and you put in the 2, and you are able to evaluate the expression now based on the value of x. Again, another review one. So how about the new stuff? Okay. The first property that's new for you guys probably is the reflexive property. Very simply, it basically says anything is equal to itself. Now I know that sounds really funny for right now, but I just want you to get used to the fact that any segment is obviously going to be equal in measure to itself, just like the measure of any angle is going to be equal to the measure of itself. We will be talking a lot more about those properties when we are looking at triangles or polygons that are sharing sides or they're sharing angles. So kind of hold that in your memory for later. The next one is the symmetric property of equality, which makes a lot of sense in saying that if A equals B, then you can flip around the equality and it'll still be true. For example, B equals A. Another way of thinking about it is if segment AB has the same length as segment CD, then segment CD must have the same length as AB. Same being true for angles as well. Again, these are most likely common sense for most of you guys, but we're just putting the fancy names for things that we already know are true. And the last one for equalities is the transitive property. Now this one is a little bit trickier because it's a 3-step process. It says if A is equal to B and B equals C, then A equals C. What we can really do is we can delete this middle part right here and take out the B's, leaving us with just A equals C. The same holds true for the equalities. You can see on the segments, if segment AB is the same length as segment CD, and segment CD is the same length as EF, then obviously we can delete the segment CD in the middle and say that AB is equal to EF. Like the symmetric property, that also holds true for angles. If the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, again we can delete the measure of angle B in between those two and just make the measure of angle A equal to the measure of angle C. Again, just getting these down in your notes, you guys. We will practice a lot of these when we're looking at specific examples tomorrow, but right now you're just getting the different properties in your notes. Okay? The last two have to do with congruence. So we're going to take these algebraic properties, which have to do with numbers, and we're going to apply those to congruence, meaning figures being congruent to each other. Okay? Sorry about the overlines on some of these, but they kind of got reformatted, but all of those are segments. So what they say basically, reflexive property, any segment is congruent to itself. the symmetric property. If segment AB is congruent to CD, then segment CD must be congruent to AB. Kind of makes sense. Transitive property, if 1 is congruent to 2 and 2 is congruent to 3, then 1 must be congruent to 3. In other words, if segment AB is congruent to segment CD and segment CD is congruent to EF, then segment AB must be congruent to EF. Okay? Lastly, there's the congruence theorems of angles. Exactly what we just said before for the segments, but that also applies to angles. So again, this is a lot of new information for a lot of you. Some of this you've seen, some of this you haven't. Right now, just work on getting this in your notes and trying to see the connections between the properties. For example, the congruence theorems of angles is very similar to the reflexive property for real numbers, let's say. So just get those in your notes, and we'll talk more about this tomorrow, you guys. Hang in there, and I'll see you in class tomorrow.